not perfect by any means, but as a whole, they looked good. There were a number of hundreds. Can you raise your hand if you got 100? So we got 2, 5, 6 hundreds, okay? That's a nice job. The biggest things that we have to be careful of, if there's a common factor, pulling it out on that number 3. You could do just the 4. You could multiply by the 4 and divide it back in. But some people forgot to divide back in by that 4. And then we got to be careful on the signs. Come on, hurry up. So just little things. Those are not huge issues. Those are little things that need to be cleaned up. I told you before, I even mentioned this to Wyatt again as he came in. All 3 of these questions were exactly off the Regents exam. And number 3, I would think would be one of the tougher ones that you're likely to see on a Regents exam. Number 2 reflects what we've talked about in class a lot lately and we'll continue to talk about today. And number 1 is more of a factoring question again. And I noticed that virtually every person got number 1 right, which means that your factoring is going really well. And notice they didn't give you an easy factoring. They gave you another factoring with a lead coefficient other than 1. If you realized that you could use the choices and multiply back and see if it does the mental check, and that's how you did it, great. There's no problem with doing it that way. That's a good thing, okay? So I was impressed with your quizzes, and I hope that it continues. Next week, we have a quiz Monday, we have a quiz Tuesday. We also have a pretest Tuesday, Wednesday, Thursday. So we have 2 last days of going over material to get it understood, and that's where we begin today, okay? Below is a graph of a piecewise function. Piecewise means it's a few different things combined at once, and we've got a linear function. It almost looks like either a line and a line or a part absolute value, part parabola, not really sure. The bottom line is that the function, now this is important, don't go getting worried about this. Notice that they did not write a function rule on the given information. They just told us 2 things here. They told us that the function is what it is. There's a chance here. The function is this. I can define a function with like f of x is x squared plus 2x, or x is the f of x is the absolute value of, or whatever. But I can also define a function with a graph. And here, they define it with a graph, and they do it over the interval from -4, which is here, up until 2, which is here. Notice the x-axis is going by halves. For some reason, at some point, I just think that the people who make these tests are just morons of the nth degree. I really do, and I'll tell you why. I also gave one to the regular 8th graders. And on those, instead of doing like a 0.51, first off, what should they do, realistically? 1, 2, 3, 4, 5. I mean, what's the point? What are we trying to prove here? But then on the 8th grade one, they went 2, 4, 6, 8. Now, can you play? And the 8th grade one was like, graph the line y equals 2x plus 4 and 1/2 x minus 1. So it's like they're intentionally trying to pick away at these littlest, teeniest points. And to me, this course is designed to see who can graduate high school, who has a solid mathematical understanding. This is picky. You want to be picky when they hit 11th grade, be picky and separate the superstar from the pretty good. But this is it's pathetic. It really is. But anyway, how I feel about it and how you feel about it is completely irrelevant. What we have to do is adjust, and we have to produce, despite the fact that there are a bunch of pure, sadistic, educationally unsound, missing the big picture idiots making this test. I love the fact that this is recorded, and I would love to discuss it with them. Now, here's the function. It's defined. It's defined as a picture, and that's fine. We have no problem with that. Then it says g of x is f of x what?
-1.
What is the role of the function of that -1? Everybody? Down 1. It's what kind of shift?
Vertical.
Vertical shift. That's the point of the question. You want to know what they want you to do? Go to here. Is that down 1?
No.
No, what is that down?
Down a half.
Down a half. How stupid is this? I mean, seriously, please. I guess that touches up there, so it goes here. See, they give you the picture and they don't even show where it touches, but they want you to go down 1. There. This. Every what I would call significant point, I come down to. All right, so to me that looks like a good graph of g of x is f of x minus 1. So the big points we're getting at so far is you can define a function with a graph, as we did on the red one, and then you should recognize vertical shift. The minus 1 outside of the parentheses just takes everything that was there before it and it subtracts 1. The output, remember, the output is, so the output is the original one minus 1. The original one's the red one. If I take 1 away from everything in red, I get blue. Make sense? Okay. Now, let's go to this one. H of x is g of x minus 2. Now, what does that suggest to you that the 2 is inside the parentheses? What is that telling you to do? Everybody?
2 to the right.
Horizontal shift 2 to the right. Now, it says to be careful here. This is 2. I almost get upset because, oh, I'm sorry. I take that back. It's g. Move 2 to the right. So I got to go to this one. Ready? 2.
What? 2, 4.
Right? I mean, what's the point? Is this a reading test? Right? Are you with me on that? I mean, just idiotic like garbage. Just stupid stuff. We're supposed to be here testing if kids get the math concept. But instead, they just have to turn around and make life miserable. And I almost think it's worse when they put this. Because doesn't that get yourself to second guess yourself?
Yeah.
Don't you read that like, oh, am I seeing it? I don't know. Oh, and you get like a queasy stomach feeling looking at the question. I'd rather they not say a word. Anyway.
Be careful here. This one might be.
Right. You know, it's just
Like
Bing!
Like the other ones on the test.
I thought you had
Like-
yeah, right. Like, oh, everything you give is just hunky dory. Okay. Any questions on this? All right. How many people are beginning to feel very confident with horizontal and vertical shift? Good. Now, the one thing that we really haven't spoken a lot about, if we go back to our general equation, and in this case I'll do a parabola. All right, but this could equally be cubic root, square root, it could be any of those functions. We've talked a lot about k, that's vertical shift. We've talked a lot about h, it's horizontal shift, and it's opposite because it's in the parentheses. We haven't talked much about a. Today we talk a little bit more about a, okay? And the role of a in everything that's going on. And you guys already have a really good idea because it was on part of your quiz today when you said that it gets narrower, I think, was the end. Right? You realize it's a number greater than 1. But we're going to talk a little bit about that today. Look, these are equal widths. How do I tell parabolas are equal widths? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. If it was skinnier, it would go up 2 over 1, or wider, it might go out there. But I can tell they're the same width. So the role of a is not important. What is the equation of the parent function here? The parent function's in red. What is it, everybody?
X squared.
Y equals x squared. All right, be a little careful about that. And now, talk to me about horizontal shift. How much have I moved over? Minor?
You're to the right.
So how do I express that in my function? X minus 3 squared. Good. There's another kind of shift going on here too. What's that other kind of shift, Leanne?
Vertical.
And how much is that?
5.
So it's y equals x minus 3 squared plus 5. Does that make sense, everybody?
Yes.
Okay. Here's the deal. If you're with us as a class, that should be simple. How many people feel that's simple? How many people feel that the question we just did is simple? Okay. If you look at that and you say, man, that's easy, I can do that all day long, I sure hope the Regents exam is chock full of questions like that, you are exactly even with where the class should be. Okay. Now, we're just going to take it one step further, and we're going to talk a little bit about the role of A. By the way, the vertical and horizontal shift stuff never changes. We have covered everything about it. It never gets any more difficult than that. Now what we're going to do is, it defines f of x as the absolute value of x, okay? And what is the definition of absolute value again? We haven't spoken about this in a while. Go ahead.
Isn't it like how far away you are from 0?
That's right, distance from 0, and the distance is always what?
Same.
It's always positive,
Positive.
right? You can't, well, if I say, how far is it from here to the wall, you wouldn't say, well, it's negative 40 feet. You would say it's 40 feet. You cannot have a negative distance. So this part is also included here, so I'm just gonna scroll up a little bit more. And f of x is the absolute value of x, so I just make everything positive, so this is gonna be 4, 2, 0, 2, 4. Make sense? Is everybody with me on that?
Yeah.
Okay, good. Now, what would 3 times f of x be?
12.
12, 6, right? Here's f of x, guys. And this says 3 times f of x. So I take the previous column and do what?
Times by 3.
Times it by 3. So 12, 6,
3.
0,
6.
6,
Minor, where'd you say that?
12. Okay. Now, next up, h of x is 2f of x. So we got to go back to the f of x column and then double it. So what do I get?
8.
8,
4.
4.
0.
Very good, Minor. 4. I know it wasn't you, trust me. 8. Excellent. Very good. Okay. Now, this time, 0.5 times what again?
2.
The f of x column. So we go to the f of x. So what do I get here?
2.
2.
1.
1.
0.
1.
1. 2.
Good. And then the last one is negative 2 times f of x, which is
Negative 8. Then
Negative 4.
0.
0,
Negative 4, negative 8.
negative 4, and then negative 8. Now, what we're really working on here, guys, is we're trying to investigate the role of the a in front. What is the role of a? What does it make it do to the graph? Andre, what do you think the 3 is going to do to the graph?
Make it like narrower.
Narrow. Good. What do you think, everybody, that the 2 is going to do? Compared to the original f of x, what will the 2 do to it? Everybody.
Make it more narrow.
Make it more narrow. Now, which one's going to be more narrow, G or H? G, because it's a bigger number. Good. What about J? What's going to happen to J compared to the original? Everybody.
Make it wide.
It's going to make it wider because it's only getting half as tall. And what about K? What's it going to do?
No.
No, it's
Narrow, but
it's
upside
going
down.
to get narrow again because of the 2. But what's the role of that negative?
Shows.
Gonna go down.
It flips it, right? It takes the y's that were positive, and when I multiply it by a negative, what's it do to them? Makes it negative, so it flips it to the bottom of the graph. So now what I'm going to do is go to our little thing here. I hope it loads up. It gave me a message before that it wasn't working right, but hopefully it does. And what I'm going to do is I'm going to put in the each of these functions, 3 absolute x, 2 absolute x, 0.5 absolute x, and negative 2 absolute x. And I'm going to look at what all of the graphs look like compared to each other. This is the step that I'm hoping works right here. Otherwise, it gets ugly and you got to do it on your calculator without me. There we go. We have progress. Booyah. Okay. Y equals. Now I'm going to leave the first one absolute x. That's nice. I'm going to clear this and I'm going to go to math,
It's on my back.
number, goes across the top. Absolute is there.
Where's the number?
You got to go scroll one column to the right. It says NUM across the top, okay? And, oh, the second one was 3x, right? So I'm going to put an x in the parenthesis, but I need to go to this side of it, so I'm going to put a 3 there. Oh, clear. Oh, I should have put the 3 first, I'm sorry. 3, math, number, absolute x, and there. Good. And then I'm actually going to do these. I'm going to do this one with it. And then after that, I'm going to do one at a time. 2, math, number, absolute x. All right, so now I'm going to graph these 3 functions. The first one will be the absolute value, y equals x, the absolute of x. This is the parent function. Then The second one graphed will be 3 times the absolute value of x, and the third one graphed will be 2 times the absolute value of x. And I want you to pay attention to the thickness or how narrow each of these graphs are. There's y equals absolute x. So look, the black one was the first one. This is the second one, and this was the third one. And it makes sense because 3 is a greater number than 2. The bigger the number, the more narrow the graph is. Does that make sense, everybody?
Yes.
Excellent, very good. Okay, now let's go back to the y equals. And again, I'm going to keep the first one, but I'm going to clear this one, and I'm going to put it was a half x or 0.5 f of x, right?
0.5.
So we're going to do 0.5, math, cross the number, enter, and then x. And then I'm going to do the -2 one. -2, math, number, absolute, x. And now I'm going to do the 3 graphs again. Now the black one is the original graph. The red one is the y equals 1/2 absolute x. And the blue one is the y equals -2 absolute x. So what we can notice here is the blue one is a little more narrow than the original black one. But because of that negative, what happens? Gets flipped. Think about it. Isn't it true that an absolute value always comes out positive?
Yes.
Because it means what again? What does absolute value mean again? Distance from 0. So normally absolute value would always come out positive, like in the original black graph. The range, remember we talked about range the other day being the y or the outputs? So if I look at these outputs in black of the absolute value function, because the y only covers the positive part of the y-axis, if I then take any positive number and I multiply that positive number by a negative number, like -2, what happens to the output? Then it's negative, right? So take any positive number, 7, multiply by -2, what do you get? -14 of the absolute value, okay? And the red one, it still keeps a positive range because 1/2 is a positive number times a positive number. It just gets bigger slower, right? Because everything is spreading out, so it's getting over. Okay, any questions? All right. Get rid of that, go to here, go to here. Now, it's going to talk about the role of K, and in this problem, I want you to realize that K is not vertical shift because they redefine it here as K being the number in front of f of x, as if it was like we usually put the A there, okay? But they're going to put K for whatever reason. What happens when the value of K is greater than 1? What does it do to the graph? James, what does it do to the graph when the value of K is greater than 1?
Makes it narrow.
Right, makes it more narrow. What if the value of K is between 0 and 1? Andre?
It makes it wider.
Wider, good. What if the value of K is exactly -1? Then what's it going to do, Wyatt?
It's gonna stay the same, right?
Same thickness, but something is going to happen.
Oh, change the side of the.
4-letter word starts with the letter F, don't get was.
From.
Not from. Flip. We actually end up reflecting it, okay? All right, next. What if it's between 0 and -1? Now what happens? Between 0 and -1, what's going to happen to the graph? 2 things are going to happen.
It's gonna get wider.
It's going to get wider, and what else?
Flip.
And it's also going to flip. Good. What if K is less than -1? Like say -3 or -5 or -1,000,000? What's going to happen? Karen? No.
Okay. It's gonna get narrower
And
and
it's less than a negative, so it's going to be a negative number. What does a negative number in front always do to the graph, Molly?
flips it.
Always flips it,
I told you wrong.
okay? Do you understand why that's narrow? Right, because if it was 3, it would make it more narrow. You want between 0 and 1 to make it wider. Okay. Homework it is. Start it up, guys. So we are pounding the heck out of these rows of A, H, and K, and we'll continue a little bit more with it on Monday. Actually, I think Monday is Simplifying Radicals Day, and then we have pretest coming.